So for this problem, I'm going to do something a little different. I'm not going to go to Desmos right away and just plug in and look for the intersections. What I'm going to do is look more at this algebraically. So in previous sections where we talked about adding and subtracting rational expressions, we knew that we had to find the common denominator. And you're going to notice that we have x plus 3 here, x minus 3, and we've got this x squared minus 9 over here. So to start this algebraically, I'm going to take that x squared minus 9. I am going to plug it into Desmos just to factor it. So I'm going to say x squared minus 9. I'm going to find those roots, and we've got that -3 and +3. And I'm going to go ahead and put that into factored form. And so let's go ahead and rewrite this whole entire statement. So I'm going to write 7 over x plus 3 plus 5 over x minus 3 equals to 10x over x plus 3 x minus 3. Let me go ahead and take that away. Once we've got that, like in previous lessons, we know we need to go ahead and find a common denominator. In this case, the common denominator, I've got an x plus 3 here, right here, and this has got an x plus 3. Well, this one needs an x plus 3, so I'm going to multiply by x plus 3 on the bottom. That's messy. I'm going to multiply by x plus 3 on the here. And then I'm going to do that to the top. And then I'm going to go through the same process. Well, this has an x minus 3. That's got an x plus 3. This has got a x plus 3 and an x minus 3. This one needs an x minus 3. Okay, x minus 3. And you'll notice all the denominators have an x plus 3 and an x minus 3. So now I can go ahead and work only with the numerators. So I'm just going to take this whole entire chunk right there and just bring it down. So 7 parentheses x minus 3. Plus 5 parentheses x plus 3 equals to 10x. And I'm just going to go ahead and distribute everything in. So 7x minus 21 plus 5x plus 15 equals to 10x. So that goes in there. Good. And start combining a little bit more, which would bring us 7x plus 10x is 12x. -21 plus 15 is -6 equals to 10x. So I've just combined that line and brought it right there. Now I'm just do some basic algebra. I'm going to subtract the 12x over and get a -2x equals to -6, and I'm going to divide by -2, and x equals to 3. All right, now that I know that x equals to 3, I'm just going to leave that there. I'm going to erase the work, and I want to go and check that in the graph that I got. So x equals to 3. And let me go ahead and erase this real quick so we don't have too much mess. We already know what the answer is. So give me a second. Okay, and let's go ahead and type this in. This is the weirdest type of problem. So 7 over x plus 3 plus 5 over x minus 3. And then 10x over x squared minus 9. And I'm going to be looking for x equals to 3. So I'm going to type in x equals to 3. Check it out. That's a vertical asymptote right there. Okay, so we know that that is a split. So there is no answer at x equals 3. So once we've found this answer and we've looked at it graphically, this illustrates the reason why it's so important to look at things graphically as well. We find, hey, this is what we call extraneous. Okay, and that just means that answer actually does not work. So x equals 3 is a condition will work inside the equation. However, if I was to put 3 in here, check it out. When we solve the problem, 3 minus 3 equals to 0. And what can we not divide by? We cannot divide by 0, and that makes this a vertical asymptote. We learned that in key features of rational functions.